Alright, so this is lesson 3-4, solving systems of equations that have three variables. And this probably looks a little bit familiar from what we've just done, but obviously there's a little more to this. So before we had like just an x and a y, and now I've added this third variable z, and before there were just the 1, 2 equations, and now there's 1, 2, 3. So we've increased the complexity a little bit here. And the goal is going to be to find the right x, y, and z that will make all three of those equations true. Now, of course, one approach to solving this would be maybe to graph it. And when we graphed these before, we found that they made lines, right? If I have an equation with x and y, usually that makes some sort of a line shape. But adding the z to this is almost like adding another dimension to it. So if I add another dimension to a line, I end up with a plane, kind of like more of a 3D sort of a figure. And you can think of a plane like a sheet of paper that goes infinitely in all directions. And if I wanted to solve this by graphing, well, I'd have to actually graph all three of those planes, because each equation would give me a plane, and see where they intersect. And I've done that here. Well, I shouldn't say I've done it. I've grabbed the diagram out of your book, and I just wanted to show you a couple of things about it. So I've got, in the diagram, I've got a red, green, and a blue plane. And if there's exactly one solution, you can see that those three planes have one point in common. So the red plane, the green plane, and the blue plane, they all share that point in the middle. And so that's the one solution, and that would be some x, comma, y, comma, z. Right? It's possible for a system of three variables and three equations to have infinite solutions, and that would mean that you know, like all three planes, they cross and make a line. So every point on this line right here is shared by the green plane, the red plane, and the blue plane. It's also possible to have no solution. So right here, the blue and the green share some points. Here, the red and the green share some points. And here, the blue and the red share some points, but there's no points that all three of them share. Same situation right here. There's no points that they all share. And in this example, they're completely parallel. So there's no point shared at all between the planes. Now, if we were actually going to solve these by graphing, that would probably be kind of challenging, because it would be hard to graph by hand for sure, but realistically we'd need like a computer tool to do that, and quite honestly there are faster ways to get the solutions. But in the end, I'm looking for the x, y, and z that make all three equations true. So we're gonna look at the algebra of it. So let me move my system down here. Like such. Okay, so we're going to solve this with algebra, and you can do this with either substitution or linear combination. I'm going to do linear combination. I think it's probably the fastest approach to solving these. And I will tell you that these are kind of big kid problems. And by big kid, I mean there's a lot of steps. And really, the steps is what I like about it. You know, when we start to do problems that are 4, 5, 6 steps long, that's really when we get your brain thinking. That's really when we get your brain handling some more complicated situations. And, you know, that's how your brain gets smarter. If you never do anything that's hard for you, then your brain doesn't grow. And so that, to me, is the benefit here. So anyway, we're gonna go through the steps to solving this particular system, and what I'll tell you is you definitely want to jot this down, because when you come to class and you have to do some of these, you're going to want an example to work off of. It's as simple as that. They'll be really hard otherwise, because trust me, you're not going to memorize how to do this. You need to have something to work off of. So okay, step one is we are going to pick two of the equations. There's three there. We're going to pick two of them. And we're going to eliminate one variable. So we're going to pick two equations, and we're going to eliminate one variable. Now, just for clarity, let me label the equations A, B, and C, just so we can talk about them easily. So we've got equation A is the first, B is the second, C is the third. Now I'm going to pick two of these. It doesn't matter which two. It could be A and B, A and C, B and C. I'm going to pick two, and I'm going to eliminate one of the variables. So it doesn't matter. I'm going to pick A and b. So equation A is 4x plus 2y plus 3z equals 1. And equation B, again, is 2x minus 3y plus 5z equals negative 14. And again, you could have picked different ones. I'm just choosing those. Now, what I have to do with them is I have to eliminate one variable. And I'm going to do that the usual way. The top equation I'm going to leave alone. So that's just 4x plus 2y plus 3z equals 1. But the bottom equation I'm going to multiply by negative 2. The reason I'm going to multiply by negative 2 is I want the x's to drop. Now, does it have to be the x's that I make go away? No, you have to eliminate one variable. Which variable is up to you? I'm picking x because it's the easiest, in my opinion. See, when I multiply through everybody by negative 2, right, here, 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 and here, I'm going to get negative 4x plus 6y minus 10z equals, now I've got to do the 14 as well. Negative 2 times negative 14 is positive 28. So I left the first one alone. I multiplied the second one by negative 2. Now I'm going to add these. Well, when I add the 4 and negative 4, they cancel. I designed it that way because when I had to eliminate one variable, I chose to eliminate x. When I add 2 and 6 together, I'll get 8y. When I add 3 and negative 10, I'll get minus 7. And when I add 1 and 28, I will get 29. And that is the end of step 1. So I picked 2 of the equations and I eliminated 1 of the variables. Alright, now step 2 is very similar to step 1. Very similar. In fact, it's almost exactly the same. I am going to pick 2 different equations and I'm going to eliminate the same variable. So I'm going to pick 2 equations and I'm going to eliminate the same variable. Now, okay, when I say pick 2 different equations, what do I mean? Well, before I picked equation A and B. So I picked the first one and the second one. All I'm saying is for step 2, I can't pick A and B again. I could still use A and do like A and C. I could do B and C, but I can't do A and B. So for this one, I think I'll pick 2 and 3, or sorry, B and C. So equation B, recall, was 2x minus 3y plus 5z equals negative 14. And equation C was 6x minus y plus 4z equals negative 1. So I picked 2 different equations. Okay, one of them's the same, but it's not the same exact 2. And then the second part says eliminate the same variable. Well, all that means is that whatever variable I chose to eliminate in step 1, which was x, is what I have to eliminate in step 2. So I can't change my mind and say, well, now I'm going to make the y's go away. I started with x, I have to stick with x. And in order to do that, I'm going to times the top one by negative 3. Hopefully you'll see really quickly why. But I'm going to get negative 6x plus 9y minus 15z equals 42 when I multiply everybody by negative 3, and I'm going to leave the bottom one alone. And see what that did. 6x, those are the ones that are going to cancel, minus y plus 4z equals negative 1. So the top one I multiply, the bottom one I leave alone. So let's add. X's cancel, have to. I got rid of x in step 1, I got to get rid of x in step 2. 8y minus 11z equals 41. And there's my answer to step 2. You say, wow, this is a lot of work and I don't really feel like I've gotten very far yet. Well, the reality is that the back part of these problems does go a little bit faster. So I eliminated x in 2 of them, I eliminated x in the other 2. That brings us to step 3. And step 3 is simply going to be to solve the system from steps 1, and 2. Now, okay, what do I mean by the system from steps 1 and 2? Well, what I mean is in step 1, we got a new equation. 8y minus 7z, that's a 7, equals 29. And 8y minus 11z equals 41. That is two equations with two variables, and you know what? You know how to solve those. We've been doing it for the last week. So, all right, I'm going to use linear combination here. Looks easy because I have an 8y in both. So I'm going to leave the top one alone. 8y minus 7z equals 29. And the bottom one, I'm going to times by negative 1 to get negative 8y plus 11z equals negative 41. So I'm doing a lot of this multiplying and adding. The y's cancel, and I'm left with 4z equals, this will be negative 12. And I can divide by 4. And finally, after all that work, I get one answer, and that is z equals negative 3. Wow, that was a lot to just get one answer. Fortunately, from here, it falls pretty quickly. But keep in mind, you know, I got the first two steps gave me two equations with two variables, and now I'm solving that. So if I found z, well, you know what? Now it would be nice to know what y is. The good news is, well, take z, and it doesn't matter which equation you input it into. Let's take this one, 8y minus 11. Well, I know what z is now. It's negative 3 equals 41. So 8y plus, that's a plus 33 equals 41. And I can solve this. We know what we're doing here. Well, minus 33, and 8y equals 8. Divide by 8, divide by 8, and y equals 1. Well, I got two of my solutions. That second one came pretty fast. So once I got one, I was able to plug it in to get another one. Well, now I know 2. I've got solution 1, solution 2. I'm still missing the x, but I know y and z. So what I'm going to do is I'm going to take one of my original equations, the one that had all three, x, y, and z. So let me go up and see what that was. So I'm going to pick one of these three. It doesn't matter which one. So let me do 4x plus 2y plus 3z equals 1. Let me do the first one. So 4x plus 2y plus 3z equals 1. 4x plus 2y plus 3z equals 1. Okay, now I just said that like 4 times because I wanted to remember it, so I didn't have to go back and look at it again. But again, I know z, I now know y, so this is not so bad. 4x plus 2y plus 3z equals 1. So I can simplify a lot of this, right? 4x plus 2 minus 9 equals 1. And really, I can keep going here. 4x, if I combine these, I'm going to get minus 7 equals 1. This is a pretty easy equation to solve now. Plus 7, 4x equals 8. Divide by 4, x equals 2. So finally, at long last, I've got my answers. All three of them. I've got 2, 1, and negative 3. So x equals 2, y equals 1, z equals minus 3. I know that's a lot, absolutely a lot, but keep in mind, if you follow the steps, you'll get your answer. So I started out by solving two equations to get rid of one variable, picked two different equations, got an equation and got rid of a variable, and those two equations, we solve that system the usual way, and we just start plugging answers back in to get our final answer. Now, I know that that's a little bit confusing. You're going to have to do a few of these before you really get a handle on it, and yeah, they are kind of long, but I know you guys can do it. So if you need to, pause the video, go back, rewatch it, figure out what's going on here, and I'll see you in class tomorrow.